All right, this is a continuation of the chi-squared goodness of fit test. We're going to talk about first critical values. So far we've used p-values and our hypothesis to test to make decisions about our hypothesis. The significant level gives us a threshold for rejecting the null hypothesis. We can consider a threshold for the test statistic in a similar way. So in the blue box, in a chi-squared goodness of fit test with the significance level, the critical value of the test is the value of the test statistic chi-squared calculation that yields the p-value equal to the critical value. The critical value is denoted by chi-squared critical. So here is a visualization . Here is your chi-squared critical value. And then you have this area under the curve called the p-value and equaling the critical value. So the critical value is shown in the diagram. Any value of the chi-squared calculation that's greater will yield a smaller p-value. Since that p-value of chi-squared critical is any value chi-squared calculation greater than its critical value, what we want to do is we want to reject the null hypothesis. So in this blue box, in a chi-squared goodness of fit test with a critical value, the null hypothesis should be rejected. So if your chi-squared calculation is greater than your critical value, then you reject the null hypothesis. So your chi-squared calculation can come from a calculator or the formula that we used on the previous video. The critical value is from a chart. And if your calculation is greater than your critical value, you're going to reject the null hypothesis. So here is the chart that I was talking about. The critical value depends on the degrees of freedom. So this is your left side. We've talked about the degrees of freedom before. Degrees of freedom is the number of categories minus 1. The right side of the chart are significance levels at 1%, 5%, and 10%. You do not have to memorize this chart. So what we'll be doing is we'll be using these 6 steps, and this is the step we're going to look at to add in from the previous video. So here's an example. A goodness of fit test is used to test the following hypothesis. So we have some probabilities. So probability 1 is 1/5, probability 2 is 1/5, probability 3, 4, and 5 are all 1/5. So that's the null hypothesis, that all of the probabilities are equal. The alternative is that at least one of them is not equal to 1/5, and the significance level is 5%. So remember that as a decimal is 0.05. And this is your alternative. And the value of the test statistics, this value right here, would have been done with the graphing calculator or your formula. Part A, write down the critical value for the test. So, how we figure this out? There were 5 probabilities. So that means there were 5 categories. So we do the degrees of freedom. 5 minus 1 is 4. So we head over to our degrees of freedom chart. We're going to look at number 4. The significance level as a decimal is 0.05. So now we go to the fifth 5%, and that critical value is 9.49. Part B. We need to figure out, should we reject the null hypothesis? So if we go back up to the top, we're looking for this rejection inequality. Is your chi-squared calculation from your calculator greater than your critical value from your chart? So your chi-squared calculation was 10.3. The critical value from the chart was 9.49. Is it true that the chi-squared calculation is greater than? Yes. So that means we're going to reject the null hypothesis. So that means that at least one of those probabilities is not equal to 1/5. So we're going to accept the alternative. At least one of them is not equaling 1/5 at a 5% significance level.